This is a quick video showing how to do review problems A, B, C, and F on the review sheet to study for the test on Monday. Review problem A states how much heat is absorbed when 43.3 grams of ice at 0 degrees Celsius and 101.3 kilopascals is converted to liquid water at 0 degrees Celsius. Express your answers in kilojoules. The first thing you should notice about this problem is that you start off with ice at 0 degrees Celsius and you're converting that to water, liquid water, at 0 degrees Celsius. So the temperature doesn't change, but the state of matter does. It goes from solid ice to liquid water. The fact that it gives you the pressure at 101.3 kilopascals, that is just standard pressure. That's the same as 1 atmosphere, and you're going to assume for this unit that all experiments are done at a pressure of 1 atmosphere, and so that's not really a factor when you are, it's just might be there to throw you off when you're calculating a problem, but you just really need to focus on the information underlined in green. So what do I know about ice being converted to water? Well, I know there's an equation that H2O is a solid. You need energy to put into that solid, and that amount of energy is 6.01 kilojoules of energy in order to convert water into water as a liquid. Now, 1 mole of solid ice, it needs this many kilojoules of energy to convert it to 1 mole of water as a liquid. So we need to figure out how many moles of water we have to begin with. If we know 1 mole needs 6 kilojoules of energy, 2 moles of water would need 12 kilojoules of energy, but we don't know how many moles we have. We do know that we have 43.3 grams of water, and if we want to try to convert that to moles, we need to use the molar mass of water. When you add oxygen and 2 hydrogens using their molar masses on the periodic table, their molar mass is 18 grams. That's the mass of 1 mole of water. Now, grams as a unit cancels, and if you take 43.3 and divide it by 18.02, you get 2.40 moles of water. Okay, now we know how many moles of water we have, and we know that 1 mole of water, we need 6 kilojoules of energy to convert it to liquid water. So with 2.40 moles of solid water, it's going to require 2.40 moles times 6.01 kilojoules of energy to figure out how much energy is needed to be absorbed to convert all that water to a liquid. We know the fact that 1 mole of water as a solid takes 6.101 kilojoules of energy, so you're going to multiply that because you have 2.40 moles, and it comes out to be 14.4 kilojoules of energy, and that is energy absorbed. It's energy absorbed because you're converting solid water to liquid water. That's the end of this problem. Let's look at problem B. Problem B, how much heat is needed to raise 30 grams of water at 50 degrees Celsius to water vapor at 100 degrees Celsius? Assume this happens at standard pressure. So what's the important information? We have 30 grams of water, and it's at 50 degrees Celsius, and we're converting it to vapor at 100 degrees Celsius. Okay, if I'm doing a changes of state problem, and all the changes of state problem that I'll give you on the test are related to water, I would draw like what I call a map of, okay, what's going to happen to this water. And in this case, you have water at 50 degrees Celsius. So I'm going to, you can see that here's 100 degrees or 0 degrees Celsius and 100 degrees Celsius. 50 degrees Celsius water, it's going to be about that point on the line. So if you're trying to convert it to water vapor at 100 degrees Celsius, the first thing that you're going to have to do is you're going to have to get it to be liquid water at 100 degrees Celsius. So that's step 1. And step 2 then is you're going to have to change the state from liquid water to water vapor. That's step 2. And so it's a 2-step problem. For the first step, it's on a diagonal where we're just dealing with liquid water, and so we can use the equation Q. For the first step, we can use Q equals MCAT, mass times specific heat times change in temperature. The mass of the water is 30.0 grams. Specific heat of water, you should have it memorized by now, is 4.184 joules over grams times degrees Celsius. And the change in temperature is you're going from 50 degrees Celsius to 100 degrees Celsius, so it's an increase of 50 degrees Celsius, 50.0 degrees Celsius. Okay, when you multiply all of this together, it gives you 6,276 joules. And that's because grams cancels and degrees Celsius cancels, and you're just left with joules as a unit in your equation. So this is how much energy is needed to just change the water from 50 degrees Celsius water to 100 degrees Celsius water. Now we need to look at step 2. Step 2, how much energy does it take to change 100 degrees Celsius liquid water into steam? So I'll do step 2 down here. For step 2, you know that liquid water is being transformed into water as a gas. This requires energy. We learned in class that it's 40.7 kilojoules of energy that it takes for 1 mole of liquid water to be transformed to 1 mole of gaseous water. We don't know how many moles of water we're dealing with. We do know how many grams of water we're dealing with. So we're going to take the 30.0 grams of liquid water and we're going to try to figure out, okay, how many moles is that? You're going to use the molar mass of water. 18.02 grams is equal to 1 mole. You're going to divide by that and it'll give you 1.665 moles of water. We know that for every 1 mole of water, it requires 40.7 kilojoules of energy to change to gas. So we're going to multiply this number by 40.7 kilojoules, and that will give us 67.8 kilojoules. Okay, so we know how much energy it takes. Step 1 is 6,276 joules. Step 2 requires 67.8 kilojoules. We need these to be the same unit because we're going to have to add all of this energy together for steps 1 and step 2. So let's convert joules into kilojoules. If you multiply this by 1,000 joules on the bottom and 1 kilojoule on the top, because 1 kilojoule equals 1,000 joules, it comes out to, this number will be 6.276 kilojoules. If we add that to 67.8 kilojoules, it gives us 74.076 kilojoules, and to significant figures, that's 74.1 kilojoules of energy. And that would be your final answer. I actually rounded a little bit too early down here with the 67.8 kilojoules. So if you get an answer that comes out to 74.0 kilojoules, it's actually a better answer. C is a little bit more difficult. It says how many grams of ice at 0 degrees Celsius could be melted by 1.200 kilojoules of heat. So it gives you the amount of heat as one of your knowns, and it asks you to find out how many grams of ice can you melt. Well, another known is that you know that solid water, it takes 6.01 kilojoules of energy in order to melt it. We discussed that in class, in order to get 1 mole of liquid water. Now, how can we use that 1 mole of solid water to transfer it to 1 mole of liquid water needs this amount of energy? Well, if you put this into a ratio, you can put 6.01 kilojoules in the denominator, because that's what you need to cancel is the kilojoules. How many moles of water can 6.01 kilojoules melt? Well, it can melt 1 mole of water. And when you do this calculation, and you take 2.100 divided by 6.01, it gives you 0.19966 moles of water. And then with this 0.19966 moles of water, we ultimately need to figure out how many grams of ice we can melt. So we know how many moles of ice we can melt. In order to convert this to grams, you're going to use the molar mass of water. This time you're going to put moles on the bottom to cancel moles. And you're going to put grams on the top. The molar mass of water, which we've worked with quite a while now, is 18.02 grams. If you multiply this out, it should give you 3.598 grams of ice. That's how much ice you could melt with the amount of energy given. The last one I want to go over, it states a small pebble is cooled to 1 degree Celsius. It is placed in a styrofoam calorimeter which contains 50 milliliters of water at 25 degrees Celsius. The water cools to a temperature of 24.5 degrees Celsius. How many joules of energy were released or absorbed by the pebble? Well, you know that the pebble was very cold, and then at 1 degree Celsius, and then it got hotter. Its final temperature was 24.5 degrees Celsius. Where did that heat come from? Well, it had to come from the water. The water was warmer. So the water went from 25 degrees Celsius to 24.5 degrees Celsius. Well, do you know more about this pebble or more about the water? Well, you know more about the water because you know the specific heat of water, and you also know the mass of the water. You don't know the mass of the pebble. So in order to solve this problem, to figure out how much heat is transferred from the water to the pebble, you can first of all try to figure out, okay, well, you know the heat of the water is going to be transferred into the pebble. So we used this equation in the past that Q of water will equal the, sorry, in this case it'll be negative Q of water will equal Q of the pebble. The water is going to be releasing the energy and the pebble will be absorbing the energy. So the same amount of energy that's released by the water will be absorbed by the pebble. Well, we know a whole bunch about water. We know, first of all, that if there was 50 milliliters of water, that means that there was also 50 grams of water in that cup, because 1 milliliter has a mass of 1 gram. We're ultimately going to use Q equals MCAT, mass times specific heat times change in temperature, to solve this problem. The mass of water is 50 grams. The specific heat of water is always 4.184 joules over grams times degrees Celsius. And the change in temperature in this case of the water, it goes from 25 degrees to 24.5 degrees. So it's going to be negative 0.50 degrees Celsius. So it lowers by 0.5 degrees Celsius. So if we do this in the calculator, 50 times 4.184 times negative 0.5, it comes out to be negative 104.6. The units on that, grams cancel, degrees Celsius cancel, and you're left with joules. So this is how much energy is transferred from the water. This negative means energy released, right? And so how much energy is absorbed by the pebble? Well, the amount of energy absorbed is 104.6 joules of energy absorbed. It has to be the same amount of energy absorbed by the pebble than energy released. So that's it. That's how you solve this problem. This is similar to problems that we've done in the past. So I hope that you learned a little bit about these review problems, and good luck on the test.